A charge of magnitude 2.94 microcoulomb is directed downward in a uniform magnetic field that is perpendicular to its velocity. The initial speed of the charge is 37.3 meters per second. The magnitude of the magnetic force on the charge is 3.15 times 10 to the negative fifth. What is the magnitude of the magnetic field? Well, we know for the Lorentz force that we can set up the magnetic force equal to QV cross B. So the cross product between velocity and magnetic field. And in this particular case, because the velocity is already perpendicular to the magnetic field, the cross product simplifies to just V times B. So the magnitude of the velocity times the magnitude of the magnetic field, because those vectors are already perpendicular. In order to solve for the magnetic field, we're going to divide both sides by QV, and we find that the strength of the magnetic field is equal to magnetic force divided by QV, where the magnetic force is 3.15 times 10 to the negative fifth newtons, divided by our charge, or 2.94 microcoulomb, times the velocity, 37.3 meters per second. And we have a magnetic field of 0.287, and that is Tesla. So 0.287, and our units for magnetic field is the Tesla. It's determined that the charge is negative. So let's put a negative here for the charge. It's traveling downwards. And the direction of the what is the direction of the magnetic field if the initial magnetic force on the charge is directed out of the screen? So we have here the force on the charge directed out of the screen. So in using the right-hand rule, we're going to point our hand in the direction of the velocity, and we want our thumb to be into the screen. You say, why into the screen if the force should be directed out of the screen? When we use the right-hand rule, that is for a charge that is positive. So if we can get the direction of the magnetic field that would put a magnetic force onto a positive charge that is into the screen, that would be a magnetic force on a negative charge that is out of the screen. So in pointing my hand down in the direction of the velocity and my thumb into the page, representing the magnetic force into the page, my fingers curl in the direction of the magnetic field, which is to the left. So in order to get a magnetic force into the page for a positive charge and a magnetic force out of the page for a negative charge, we need a magnetic field that is to the left.